Hello and welcome to this video. I am Karnesh Johri and this video is about awk command in Linux. Awk is a domain-specific programming language suitable for text processing, data extraction, and report generation. Using awk, we can process large log files efficiently and generate reports. Awk was developed by Alfred Aho, Peter Weinberger, and Brian Kernighan in 1977. The name awk is derived from the surnames of the authors. Present-day Linux systems have Gawk, which is an implementation of awk, and more. Awk is a symbolic link to Gawk on Linux systems. And we start with the command syntax of awk.
The awk command can be invoked as awk (options) code program followed by one or more files. Whatever is enclosed in brackets is optional. The second way to invoke awk is awk (options) -f program file followed by one or more input files. As you can see, the basic difference between the two invocations is that in the first case, the program is given on the command line, whereas in the second case, the program is in a file passed with -f option. You can have -f option multiple times in an awk command. Also, you might have noticed that there is an optional double hyphen in both cases. Double hyphen can be used to signal end of options to the awk command. It is for those rare use cases where a file name starts with a hyphen. So the awk command basically has an awk program which operates on input files. Actually, it is a filter. If there are no input files, it reads standard input and it writes on standard output. What is an awk program like? An awk program comprises of one or more pattern action pairs. A pattern could be a regular expression or it can be a C language style conditional expression. For example, length parenthesis $2 greater than 12. The action is a list of awk commands. Awk reads one line of input at a time. It then scans the first pattern. If there is a match, it executes all statements in the corresponding action. It does that for all pattern action pairs, and this repeats for rest of the input. If a pattern is missing, all lines of input are matched. If an action is missing, the default is to print the matched line. There must be at least one pattern or one action in an awk program. You can make an executable awk program much like a shell script. All you need to do is to save the awk program in a file. Let's say we wish to find all files in the current directory which have been modified in the month of February. We call this febfiles and we open the file febfiles. The first line is the shebang and it is #user/bin/awk -f and the program is one line $7 equal to fab print $0. Before we run, we need to make febfiles executable. We do that chmod +x febfiles and we can run it now. It works. Now we look at some of the commonly used command line options. -f fs or -- field separator fs. This sets fs as the field separator. The default field separator is white space, for example, sequence of space or tab characters. You can even make a regular expression as a field separator, for example, a comma followed by spaces. Then -f source file or -- file source file. The awk program is from the source file and not from the first non-option argument. The -f option can be given multiple times and the awk program is the concatenation of contents of the specified files. Then there is -e program text or -- source program text where you provide awk program source code on the command line. So with -e and -f options, you can mix code in file and code on the command line. -e file or minus minus exec file. Read awk text from the file. This is similar to minus f option, but there are significant differences. Minus uppercase e terminates option processing. Whatever is there after minus uppercase e is passed directly to the awk program. Command line variable assignments are not allowed. This is useful in World Wide Web CGI applications as it prevents a malicious user to pass arguments or code as parameters in the CGI script URL. All you need to do is to put the shebang as hash exclamation mark slash user slash bin slash awk minus uppercase e as the first line of the executable awk program file. Minus uppercase p or minus minus POSIX is for running awk in the strict POSIX mode. The GNU extensions are disabled. Now we look at important concepts in awk, and the first is fields. Awk breaks down each line of input into fields, namely $1, $2, $3, $NF. The default field separator is one or more spaces and or tabs. The variable NF contains the number of fields in a line, and $0 is the entire line of input. Suppose you wish to print top 5 processes with maximum CPU utilization, you can say ps-ef minus minus no headers minus minus sort minus pcpu pipe to sed quote 5q unquote pipe to awk quote brace print $1, $2, $4, $7, $8 brace unquote. This prints user ID, process ID, CPU utilization, which is CPU time used divided by the time the process has been running and expressed as a percentage, cumulative CPU time, and the command used for creating the process. The built-in variable NF is the number of fields in a line. So if you wish to delete all blank lines in a file, you can say awk quote NF greater than 0 brace print brace unquote file name. The default field separator is spaces, and if you wish to change it, you can do that with the minus f option. So for processing /etc/password file, we can say awk minus f colon quote brace print $1 brace unquote /etc/password, and this prints the user ID of users in the password file. Next, awk built-in variables. These variables are initiated and updated by awk. They can be read and changed by the program. So here's a list of some of the variables. These are file name, which is the file being processed currently by awk. F is the field separator, which by default is tabs and spaces. NF is number of the fields in input line or record. Each line read by awk is considered an input record, and each line of output is output record. So NF is the number of fields in an input record. NR is input records number or line number. Since the beginning of program execution, it is incremented every time awk reads a line. FNR is the current record number of the current file. RS is the input record separator. The default value is new line. OF is the output field separator. The default value is spaces. ORS is the output record separator. The default value is new line, and so on. As an example, here is an awk program using built-in variables, file name and NR, and it operates on one or more files. For each file, it prints each line with line number and file name. Whenever the file name changes, it sets record number NR to 1 and prints a blank line. Then for each line, it prints the record number or line number, file name, and $0, which is the entire line. Here we are setting NR to 1 for each file. We can avoid that by using the built-in variable FNR, which has the current record number for the current file. We can use FNR and the program becomes simpler and the output is the same, sans the blank line between files. Special patterns begin and end. We have seen that the awk command syntax is awk options program file. The program comprises of one or more pattern action pairs. There are two special patterns, begin and end. If the program has a begin pattern, the corresponding action is executed before any record is read. It is for initializing variables, printing headers, etc. Initializing variables to 0 is not required as awk does that by default. The action related to end pattern is executed after the last line of input has been processed and is useful for printing summary, grand totals, etc. For example, we have a comma separated file expenditure.csv with expenditure under different heads for last 3 years and we wish to find the expenditure for each year. We can write a small awk program to do this. We set comma as the field separator in the action for begin pattern. For the first record, we print the fields and from second record onwards, we print the values for each year and also add values to the sum counters. And at end pattern, we print the totals. And when we run the program, we get the total expenditure for each year. And now we look at operators in the decreasing order of precedence. The increment and decrement operators have the highest precedence. Next operator caret is for power. Then we have star, slash, and modulus for multiply, division, and remainder, followed by plus and minus for add and subtract, and then there is nothing. That is no operator between two strings. When there is no operator between two strings, the strings are concatenated. For example, if A is X and B is Y, then if we print A, B, then we get X, Y. And we have relational operators greater than, equal to, less than, equal to, not equal, and the tilde operator for matching a string with a regular expression. That is, A tilde B is true if string A matches regex B, and similarly, A exclamation tilde B is true if string A does not match regex B. Then the exclamation mark for negation and logical AND and logical OR. And finally, the assignment has the lowest precedence and plus equal to, minus equal to, star equal to, slash equal to, percent equal to, tilde equal to have the usual meanings, which is y operator equal to expression is y equal to y operator expression. And now we have the control statements used in the action part of the awk program, and these statements are if else, while, do while, for, switch, break, continue, and exit. These work mostly like in C language, but there are two statements which are different in the sense that these are not there in C language, and these are next and next file statements. The next statement causes awk to stop processing current record and go to the next record. Similarly, next file causes awk to stop processing the current file and go to the next file. Type and conversions. In awk, all variables are untyped at the start. Then, as the program progresses, variables are typed dynamically depending upon the context. The type of function gives the type of a variable. For example, here we try to print type of A where A has not yet been used previously and we get type of A as untyped. And if we assign value to A, its type changes accordingly. So if we assign a value 77.25, A has a type number, and subsequently we assign A the value hello world, A has a type string. And we can say there are two basic types of a variable in awk, which is number and string. Awk converts a number to string and vice versa depending upon the context. Suppose you add a number to a string. The string is converted to a number and the addition is done. How is the string converted into a number? If the string starts with a number, it is converted into that number. For example, if a string is 45 world, it is converted to the number 45. If there is no number at the beginning of string, it is converted to the number 0. So if A is a string with value 45 word and we add 20 to it, we get 65. Similarly, a number is converted to a string when a string operation like concatenation is done. A number is converted to string using the format specified in awk built-in variable convfmt. The default value of convfmt is percentage point 6g, and you can change it. So if we concatenate 45 and 5.12345667, the later is converted to 5.12346, and the two numbers are converted to strings, and the concatenation result is 455.12346. If you need to convert a number to a string, just concatenate it with a space. Like most programming languages, awk provides arrays. The arrays in awk are very different from arrays in C language. There is no declaration for arrays, and the size of an array is not prefixed. And most importantly, the array index is a string. It can be any valid string. Awk arrays are associative arrays, a collection of key value pairs. For example, an array may contain apple 5, orange 2 dozen, grapes many, 1 unnamed. This is just to show that any string can be the index. Since awk converts number to string and vice versa based on context, the last element index 1 is automatically converted into a string. We can say there is an array fruit. Fruit apple is 5, fruit orange is 2 dozen, fruit grapes is many, and fruit 1 is unnamed. And we can print it. The order of elements is not definite. It can be any order. There is no such thing as the 0th element or the first element, etc. We'll look at the order of elements a little more. But first, let's look at the for statement for I in fruit printf, or generally for var in array body. This is a special kind of for statement for traversing the entire array, and in this case, printing each element. As I said earlier, the order processing of array elements is arbitrary, but as a user, you can change it as per your requirements. And this is done using the built-in array element procinfo sorted in. You can set procinfo sorted in to a certain value to get the corresponding sorting order of array elements. Procinfo sorted in can have many values. We'll look at some of them, and these are at unsorted, which is the default awk behavior, at indstrasc, where indexes are treated as string and the array is sorted in the ascending order of index. Similarly, we can set at indstrsc to get array sorted in descending order of index being treated as string. Similarly, you can have procinfo sorted order as at indnumdsc for index treated as number and array sorted in descending order of index. Non-numeric indexes are treated as zeros. And then there is also at indnumASC for sorting array in ascending order of index, which is treated as a number. Similar to index, we have got sorting order on the basis of value, and these are at val str asc, at val str dsc, at val num asc, and at val num dsc to get the array sorted in ascending or descending order based on value, treating the value as string or number. Just to see this in action, in our example, the array was earlier printed in unsorted order, and we have an awk script where we set the built-in array element procinfo sorted in as at indstrsc to get array printed in the descending order of index being treated as a string. And for index string ascending order, we set procinfo sorted in as at indstrasc, and it works. We'll look at sorting array on value also, setting procinfo sorted in as at val strasc sorts the array with values being treated as strings coming in ascending order, and setting procinfo sorted into at val strdsc sorts the array in descending order of value treated as strings. Array operations. We have seen we can add an element to an array by assigning a value. We can also modify value of an array element by reassigning a new value. We can delete an existing element in an array. To find whether an element exists in an array, there is the in operator. The usage is index in array, and we can delete an element by the statement delete array index. For example, we have four elements in the array fruit. We can check whether there is an element with the index apple with a statement if apple in fruit. And on success, we delete fruit apple. And when we print all elements of the array fruit, there is no element with index apple. Awk provides multidimensional arrays. Multidimensional arrays are those where multiple indexes are used to access elements. For example, xij is an element in a two-dimensional array and yijk is an element in three-dimensional array. What happens in standard awk is that multiple indexes are concatenated to form a single index, and then the array effectively becomes a single dimensional array. Multiple indexes are concatenated with a separator in between. The separator used is the value of the built-in variable subsep. The default value of subsep is octal 34. So if an array element is xijk, it is stored as xi octal 34 j octal 34k. We can use the in operator to check whether a particular index sequence occurs in a multidimensional array. For example, if food, fruits, citrus, oranges equal to 5, and we check if fruits, citrus, oranges in food, then we get the confirmatory message that it does. Suppose we scan a multidimensional array, we do not get the individual indexes right away. Awk stores concatenated indexes as a single index. But since there is a subset separator between the individual index values, we can split the combined index into individual indexes using the split statement. The first parameter is the combined index, and the second parameter is the individual array in which individual indexes are returned, and the third parameter is a separator character which is subsep by default. Split returns the number of individual indexes, and most important to note is that indexes in the individual array start from 1 and not from 0. As an example, we split the combined in food and we get the individual indexes as fruits, citrus, and oranges. The multidimensional arrays we have seen are part of the standard awk. The GNU awk or GAWK goes beyond this and provides true arrays of arrays where an array element itself can also be an array. For example, x10 is equal to 12, x11 equal to 14. So here we got at index 1 a subarray with two elements x10 equal to 12 and x11 equal to 14. There must not be any space between the brackets. The index can be any awk expression. For example, x1 shaft equal to 20 mm diameter, x1 bearing equal to roller, x1 key equal to taper, x2 boxes 2 equal to 12, and x3 2 1 space equal to 15. In such arrays, the term dimension, row, column are not very meaningful, but we can say that the term dimension refers to the maximum number of indexes required to access an element in the array. Now, what are the operations we can do here? We can delete an element. For example, delete x1 followed by x1 equal to 15. This deletes the subarray at x1 and inserts a scalar value 15 in its place. Next, we can find the number of elements in an array using the length function. So x has 3 elements, x1, x2 and x3, and x1 has 4 elements, x1 shaft, x1 bearing, x1 key, and x1 toolbox. The isArray function is useful for testing whether an element itself is an array. If we know the maximum number of indexes, we can traverse an array using the for var in array statement and isArray function. Here we have an array x and maximum indexes are 4. We start with array x and traverse using the for var in x statement, and for each element we check whether it's an array. If it is an array, we again traverse it using the for var in array statement. Otherwise, we print the element and we get the printout of the entire array. It is in no particular order. Maybe we should have set the built-in variable procinfo sorted in 2 at indstrasc to get a better looking array printout. Now we look at some of the built-in functions available in awk which can be used in awk programs. A10to yx is the arc tangent of y/x in radians. Cos x is cosine of x where x is in radians. Expx is exponential of x, that is e to the power x. G sub, regex, replacement, optional target. G sub is for global substitute function. The first parameter is a regular expression, regex, and the next parameter is the replacement string, and finally the optional target variable. G sub works on the contents of the target variable, and if target is not given, it works on $0, that is the entire line of input. For example, awk begin x equal to she sells seashells by the seashore. G sub regex is C, replacement string is uppercase C, target is X, print X. We want to replace SCSC with uppercase C. Since the first argument is a regex and regex needs to be enclosed in two forward slashes and the uppercase C and target is X. And we get a print of X with substitution in two places. Next, sub regex replacement target. Sub is same as G sub except that it is not global, only the first occurrence of match is replaced with replacement. Index S1 S2 returns position of string S2 in S1. String indexes start from 1, returns 0 if not found. Int expression, integer of expression with the decimal part getting truncated. Length, optional string, length of string or that of $0 if string is not given. Then log x is the natural logarithm of x. And next, match string regex optional array. Search the string for longest leftmost match of regex. This function returns the index of match in string. If no match is found, 0 is returned. If array is present, 0th element contains part of the string matched by regex. If regex contains parentheses, array indexes 1, 2, etc. contain corresponding matched subexpressions. Also, multidimensional subscripts provide start index and length of each matched subexpression. For example, echo uppercase B, AA, ZZZZ, ball, pipe to awk, match, $0, regexes, parenthesis, B pipe B, parenthesis close, A plus, Z plus, parenthesis close, parenthesis B, A plus, L plus, parenthesis close, slash, comma, ARR. We print ARR0 which contains the matched string, ARR1, ARR2 and ARR3 contain the matched sub-expressions in parentheses. And next three lines, ARR1 start, ARR1 length, etc. give the start index and length of the matched sub-expressions. Next, RAND returns a random number between 0 and 1. Sin x is sin of x in radians. Next is split, string, array, optional field separator, optional seps. We have seen split in earlier examples and it is very useful. Split divides the string into pieces separated by field sep. The pieces are stored in array 1, array 2, etc. If field sep is not specified, the value of the built-in variable fs is used. If seps is passed, the separator between the pieces in array I and array I plus 1 is stored in seps I. Split returns number of pieces in array. Next is the familiar sprintf format expression 1, expression 2, ... Sprintf returns the string which would have been printed by printf with the same arguments. Of course, as printf doesn't print, it only returns the string. Sqrtx gives the square root of x. Srandx sets the seed of the random number generator. If x is not given, the current system time is used. Substr sm optional n returns the substring of string s starting at index m of length n. If n is not given, substr returns the entire suffix of string starting at position m. To lower string returns a copy of string with each uppercase character replaced by its lowercase counterpart. To upper string is the converse of to lower function. It returns a copy of string with each lowercase character replaced by its uppercase counterpart.
And we come to the end of this video. You can find all this information at https://tiny.1/awk77. Please subscribe to SoftPrayog for software related videos. Thanks very much for watching. Take care and stay safe.